Prove that the roots of the equation a square minus bc into x square plus 2 into b square minus ca into s plus c square minus ab equal to 0 are equal if either b equal to 0 or a cube plus b cube plus c cube minus 3abc equals to 0. Now given equation is a square minus bc into x square plus 2 into b square minus ca into x plus c square minus ab equal to 0. This is equation 1. Therefore, discriminant of this equation is this is discriminant square of coefficient of x minus 4 into coefficient of x square into constant term. This is discriminant. By simplifying this discriminant, we get 4 into b to the power 4 minus 2 into b square ca plus c square a square minus 4 into a square c square minus a b minus a cube b minus b c cube plus a b square c. By taking 4 common from the above line, we get b to the power 4 minus 2 b square ca plus c square a square minus a square c square minus minus a plus a cube b minus minus plus b c cube minus plus minus a b square c. By cancellation, these two a square c square a square, and there is no more cancellation. So a cube b plus b to the power 4 plus b c cube minus 2 b square ca minus a b square c, so minus 3 a b square c. By taking common b is common, so within bracket this one becomes a cube plus b cube plus c cube minus 3abc. Now see that roots of the given equation are equal. Since roots of given equation be equal, then discriminant equal to 0. So discriminant equal to 0 means that one is equals to 0. So 4 into b into a cube plus b cube plus c cube minus 3abc equal to 0. So either b equal to 0 or a cube plus b cube plus c cube minus 3abc equal to 0. This is our required proof.